Hello. Okay, so the purpose of these videos, these 4 videos, are just to kind of recap what we've gone over in the last couple of sections. I know we went a little bit fast, but just want to make sure everyone's kind of on the same pace. Okay, so but here we go. This is just a review. So dilations are non-rigid transformations that preserve shape but not size. So if you look at this, if you're going from the smaller to the bigger one, the shape is preserved but not the size. So for example, I have on my phone, took a screenshot of SpongeBob. So if I were to make him bigger, that is an example of an enlargement. If I make him smaller, that is an example of a reduction. Okay, so that leads to scale factor. So scale factor is the ratio of the lengths of corresponding sides in the image and the pre-image, and that is the main purpose of this section. So when you're starting with the smaller dove and make it bigger, the scale factor, if we call the scale factor k must be greater than 1. If we start with the bigger dove and make it smaller, that is called a reduction. So instead, if we have a reduction, it must be a fraction or a decimal between 0 and 1. Okay, so I'm going to show you an example. This is the example that we did in class. Okay, so determining the scale factor and the algebraic row. Okay, so what we have here is we have A, B, and C. And this is A prime, B prime, and C prime. Maybe if it's easier, you know what, I'm just going to put this on the side. That's how we've been doing it in class recently, just so you can kind of look at it better. Okay, I'm just going to cross that out. Okay, so if we look at the relationship between the pre-image and the image, notice here, if we look at our x's, when determining scale factor, you're either multiplying or dividing something. Don't worry about adding or subtracting anything. Only thinking about multiplying or dividing. So here, 2 times 2 is 4. Negative 2 times 2 is negative 4. And we also know 0 times 2 is 0. So this, we know that our x's are multiplied by 2. So that's the first part of this algebraic row. It always starts with x comma y. And it has a 2x. Okay, so the next part here, we look at our y's. Our y's are also multiplied by 2. 2 times 2 is 4. Negative 1 times 2 is negative 2. Negative 2 times 2 is negative 4. So the algebraic row for this is 2x, 2y. So we're going from the smaller pre-image to the bigger image. So if you're going from small to big, basically the scale factor is going to be 2. So I'm just going to write that there. Scale factor is going to be 2. You can think of it as 2 over 1 or 2 to 1. So that is the scale factor that goes here. The scale factor is 2 to 1. This is called an enlargement. When you're going from the smaller image to the bigger image. Okay, so the next one here, determining the scale factor and algebraic rule. This one here, you know what, I'm just gonna do the same thing we did earlier. Just write it all out. Just put it side by side. I think that's probably easier for you guys to see. A prime is negative 1, 2. B prime is 2, 2. C prime is 1, negative 1. D prime is negative 2, negative 1. Okay, so these are my coordinates on this graph. So if we were to look at the relationship between the x's and the y's, now we have 2 divided by 2 is negative 1. 4 divided by 2 is 2, etc., etc. That means the x's are divided by 2. So you can think of it as 1/2 x. You could put x over 2. That is fine. Okay, this next part here. So you have these y values and these y values here. So if you look at the relationship between here, 4 divided by 2 is 2. 4 divided by 2 is 2, etc., etc. One thing to notice about when you're writing this algebraic row, this number should be the same as this number. erase that. So yeah, just like this one, if you notice x's are multiplying by 2, the y is also multiplied by 2. And then for this one here, the x is divided by 2, that means the y is divided by 2. So my scale factor in this case is 1/2. Now you can think of this as 1 to 2. Yeah, so that's another way that you can write it. Scale factor is 1 to 2. Okay, and this here is called a reduction. It's called a reduction because we're going from the bigger image and making it smaller. We're making SpongeBob smaller. Reduction. Okay. Okay, so the next part, the last thing I went over in class was this example. Okay, so if you had, one way to do this is, yeah, you can use a ruler. Okay, so if I use this ruler, it says centimeters. Okay, centimeters. So each little marking is a centimeter. So AB right here, this says this is 6 centimeters. AC right here is going to be 4 centimeters. BC is going to be 3 centimeters. Okay. AB is going to, A prime, B prime is going to be 3 centimeters. A prime, C prime is going to be 2 centimeters. And B prime, C prime is going to be about 1.5 centimeters. Okay. So, this next part here is where you're probably going to need a protractor. So I have a protractor right here. You guys can see that. Okay, so measure of angle A. When you're reading the protractor, I don't know if you remember from module 2, you put the crosshair over the vertex of the triangle. So this right here is about 27 degrees. Measure of angle A is going to be 27 degrees. If we put it on A prime now, we notice it's about the same. So if you had to read up there, sorry, that's a little bit of the glare, it's about 27 degrees. This is 27 degrees. Measure of angle B. Measure of angle B is this one here. So this is the crosshair, lines up with the vertex. This is about 36 degrees or so. We'll put 36. Measure of angle B is going to be about that much as well, 36 degrees. So from here, what we know is we know these two angles. So in order to solve for the other one without using a protractor, you can just subtract from 180 degrees because the angles in a triangle add up to 180. So 180 minus 27 minus 36. So that is going to be about 117 degrees. So that means this one here is 117 degrees. Okay. Let me see, 117 plus 27 plus 2. Yeah, okay. Okay, so this next part here, it says complete the following ratios. So in order to complete the following ratios, this is just A prime, B prime. So A prime, B prime is 3. AB is 6. So 3 divided by 6, this is 1/2. This is also 0.5. Okay. The next part here, if you want to find A prime, C prime, this is straight from here. This is 2. AC is 4, so this is 1/2. This is also 0.5. B prime, C prime, so this is 1.5. BC is 3, so this is this is also 1/2. This is just 0.5. Okay, so this is basically an introduction into what we've gone through recently, which is called similar triangles, or just similar figures in general. So with similar figures, what we know is that these angles have to be the same, these angles have to be the same, and these angles have to be the same. So this is what we just explored right here. The only thing that changes now are the sides. So the sides, notice this side is not the same as this side is not the same as this side, and this side is not the same as that side. So these sides are called, they're proportional to each other. So proportional meaning you can set up a ratio, and if all these ratios are equal to each other, that means the triangles are similar to each other. If you find like certain numbers that don't match up, where all these ratios are not equal to each other, then the triangles are not going to be similar to each other. So this is just a brief overview into the next sections actually that I'm going to go over anyway if you missed it. So this is, if I had to label it, this is 6, this is 4, this is 3. We know A prime B prime is 3, A prime C prime is 2, B prime C prime is 1.5. Okay. And actually what you'll learn later is this is called side similarity. If you knew all three sides are proportional to each other, that is called side similarity. And I'll get to that later in section 11.4. But this basically covers everything that I wanted to cover in 11.1. Yeah. Okay. Thanks. That's it. See you in 11.2.